Another example is you have to compute y of 0.5 and the differential equation given is y double dash plus y equals to x square, and the boundary condition is y of 0 equals to 0 and y of 1 equals to 0. So now again we need to consider wi of x equals to x raised to I 1 minus x, and t of x equals to summation alpha I wi of x. Okay, and this I goes from 1 to n, and n is nothing but whatever the power of differential equation is. So now we have to check whether this condition satisfies the boundary condition or not. So here it also satisfies. So now as we have t of x, we have to consider w1 of x as x into 1 minus x, and this will give you t of x as alpha I, that is alpha 1 into x into 1 minus x. So now you have to integrate 0 to 1 r of x into w1 of x. So for this you need to find r of x, which is equal to substitute value of t into the given, that is t double dash plus t equals to x square, that is minus x square, so dx. So this will give you integral 0 to 1 t double dash plus t minus x square into alpha w1 of x is nothing but alpha 1 into x minus x square dx. Sorry, it's not alpha 1 because it is just w1 of x, which is nothing but x minus x square. So it is integral t double dash plus t minus x square into x minus x square dx. Now we have to equate it with 0, and this will give you integral. I have to separate this integral, so integral 0 to 1 t double dash into x minus x square dx plus integral 0 to 1 t into x minus x square dx minus integral 0 to 1 x square into x minus x square dx, which is equal to 0. Again you have to consider this separately. You have to solve it with integration by parts. So I'll directly write down the answer. So this integral double dash t double dash x minus x square dx is equal to minus 2, because it is same as that of previous one. So it is minus 2 into integral 0 to 1 t dx plus integral 0 to 1 t into x minus x square dx minus integral 0 to 1 x cube minus x raised to 4 dx, which is equal to 0. So now using the given whatever we have found it out in the equation, we will get minus 2 integral 0 to 1 t dx plus integral 0 to 1 t into x minus x square dx minus integral 0 to 1 x cube minus x raised to 4 dx, which is equal to 0. So this will be minus 2 into, again substituting t as alpha 1 w1, so you'll get alpha 1, which is constant, into integration of 0 to 1 x minus x square dx plus again alpha 1 outside, integral 0 to 1 x minus x square whole square dx minus integral 0 to 1 x cube minus x raised to 4 dx, which is equal to 0. Now solving this, you will get minus 2 alpha 1 into x square upon 2 minus x cube upon 3 over 0 to 1 plus alpha 1 into x square. So that's that square, so it will become x cube upon 3 minus 2x raised to 4 upon 4 plus x raised to 5 upon 5 from 0 to 1 minus x raised to 4 upon 4 minus x raised to 5 upon 5 equals to 0. So now substituting the limits, you'll get minus 2 alpha 1 into 1 upon 2 minus 1 upon 3 plus alpha 1 into 1 upon 3 minus 1 upon 2 plus 1 upon 5 minus 1 upon 4 minus 1 upon 5, which is equal to 0. So after this you'll get alpha 1 into 1 upon 30 minus 1 upon 3 equals to 1 upon 20. So alpha 1 will be nothing but minus 1 upon 6. So you got the value of alpha 1. So trial function t of x will be minus 1 upon 6 into x minus x square. Y of x is nothing but minus 1 upon 6 x minus x square. So this will be y of 0.5 equals to minus 0.0416. So this is the value of y. So again, to find the exact solution, you have to follow the same procedure. So you are given y double dash plus y minus x square equals to 0. So now you have to convert it into form of d square plus d. So now this will become d square plus y. So that's one common. So d square plus 1 into y equals to x square. So now you have to consider this equation. So d square plus 1 equals to 0. Again d will be equal to plus or minus I. Same CF will be equal to C1 cos of x plus C2 sin of x. So to find the particular integration, you need to have formula 1 upon fd x square, which is equal to 1 upon d square plus 1 x square. So 1 upon d square plus 1, it is similar to 1 minus d square plus d raised to 4 minus d raised to 6 up to so on x square. So now this will become x square. 1 into x square is x square minus double derivative of x square is nothing but 2. So this will be 2. So x square minus 2. So y of x, you got it as c1 cos x plus c2 sin x plus x square minus 2. Now you have to make use of initial condition to find value of c1 and c2. So y of 0 equals to 0. So substituting 0, you'll get 0 equals to c1 cos of 0 plus c2 sin of 0 plus x square, that is 0 square minus 2. So now c1 will be equal to 2. Similarly, we'll have to make use of y of 1 equals to 0. So 0 will be equal to c1, which is equal to 2. So 2 cos of 1 plus c2 cos of 1 plus 1 minus 2. So this will be nothing but 1 equals to 2 cos of 1 plus c2 sin of 1. So value of c2 is 1 minus 2 cos of 1 upon sin of 1. So you got the value of c1 and c2. You have to substitute it in this equation. So you'll get y of x equals to 2 cos x plus 1 minus 2 cos of 1 upon sin of 1 sin x plus x square minus 2. So have to substitute y of 0.5. So x equals to 0.5. You have to calculate. You'll get minus 0.04076. So this is one method to solve Galerkin's method. Now another way, it's more simple than this. So let's see that. Now another method is solve the boundary value problem for x equals to 0.5 and the given differential equation is the square y 20x square plus y equals to minus 1. In first condition is y of 0 equals to 1 and the other boundary condition is y of 1 equals to 1. So now what you have to see is the power of the given differential equation. So if power is, if you know, denoted by n, then if it is 2, then you have to consider one degree of polynomial n plus 1. So now this will be a degree of polynomial 3. So let us denote it with y, which is equal to c0 plus c1x plus c2x square plus c3x cube. Okay, so this is one polynomial of degree 3. Now we have to apply the boundary condition. So applying the boundary condition, so applying boundary condition for x equals to 0, we have y equals to 1. So substituting this in this equation, you will get 1 equals to c0 plus c1 into 0 plus c2 into 0 square plus c3 into 0 cube. So you got the value of c0 as 1. Okay, so this is 1. Now you have to use the second boundary condition, that is for x equals to 1, y equals to 1. So substituting it, this is y1 equals to, now c0 we have got the value as 1, so you can directly substitute here, plus c1 into x, that is 1, plus c2 into 1 square plus c3 into 1 cube. Okay, so this will give you 0 equals to c1 plus c2 plus c3. So now as we have found or calculated c0 as 1, you can consider c1, which is equal to minus c2 minus c3. So we have to write c1 in the form of c2 and c3. Now we have to substitute this value of c0 and this c1 in this equation 1. So suppose this is equation 1. So substituting value of c0 and c1 in equation 1. So what you'll get is y equals to c0 is 1 plus c1 is minus c2 minus c3 into x plus c2x square plus c3x cube as it is. Okay, so now you need to consider that c2 outside, so you have to take c2 common and c3 common. So now this will be equal to 1 plus, if you take c2 common, then it will be just minus x plus x square, and there if you have taken c3 common, then it will be minus x plus x cube. Okay, so now this is a second equation where y equals to 1 plus c2 into minus x plus x square plus c3 into minus x plus x cube. Now this, whatever the coefficients of c2 and c3 are, these are nothing but w1 and w2, which you have taken directly in the previous example. So now here we have calculated what exactly w1 and w2 is. Okay, so now as you see, this is y, and in the given differential equation we have d square y by dx square. So now we need to differentiate this y 2 times so as to get the value of d square y upon dx square. So first of all, differentiating equation 1 or equation 2, sorry, this equation 2, what we'll get is dy by dx equals to, this is constant, so it will be 0 plus c2 is again constant. Now derivative of this is minus 1 plus 2x plus c3 is constant, again minus 1 plus 3x square. Okay, so this is first derivative, and again we have to differentiate this. So again differentiating the above equation, you'll get d square y upon dx square equals to, now this will be nothing but, this is 0, so now this is constant, so this is 0, 2x is 2, so it is 2c2 plus, again minus 1 is constant, so this will become 0, then this is 6xc3. so this is what we got. And now suppose this is equation 3. Okay, so now what we have is our main equation, differential equation, d square y by dx square, we have found its value in equation 3. Then y, we have this equation in equation 2, a value of this y in equation 2. Now you have to substitute both this value in this given differential equation. So substituting this 2 and 3, what we will get is d square y upon dx square plus y equals to minus 1. So this is 2c2 plus 6xc3 plus y is 1 plus c2 into minus x plus x square plus c3 into minus x plus x cube, which is equal to minus 1. Okay, so again you need to take c2 and c3 common. So if you take c2 common, then what you'll be getting is 2 minus x and plus x square, so this is plus x square plus c3 into 6x minus x plus x cube, and you have to take this plus 1 and this plus 1, so this is 2, which is equal to 0. Now whatever you got, so this is c2 into 2 minus x plus x square plus c3 into 6x minus x, that is 5x. So we have to write it this c2 into x square minus x plus 2 plus c3 into, so it is x cube plus 5x plus 2 equals to 0. So now this is our residual function r of x. Okay, so now we need to find this value of c2 and c3. For this you have to take the integration, again integration r of x into w of x. Okay, so for this first, so it is ix dx. Okay, so now first we will calculate is integral, boundary condition are 0 to 1, so integral over 0 to 1 w1 into r dx. So now what is w1? It is nothing but minus x plus x square into r is what we have found it out, c2 into minus x plus x square plus 2 plus c3 into 5x plus x cube plus 2 dx. Okay, so you have to solve this integration. So what you'll get is, so integral 0 to 1, again you need to take c2 common, So while taking c2 common, what you'll have to do is you have to multiply this with this bracket. So you will get x square minus x cube minus 2x minus x cube plus x raised to 4 plus 2x square plus c3 into minus 5x square minus x raised to 4 plus 5x cube plus x raised to 5 plus 2 into this, so it is 2x square minus 2x dx. Okay, so this is what we have. Now we can solve this. So you have to take this like terms, so 0 to 1 c2 into x raised to 4 minus 2x cube plus 3x square minus 2x plus c3 into x raised to 5 minus x raised to 4 plus 5x cube minus 5x square plus 2x square minus 2x dx. Okay, so now need to integrate this. So c2 into integration of this, because c2 is constant, you can take it outside. So x raised to 5 upon 5 minus 2 x raised to 4 upon 4 plus 3x cube upon 3 minus 2x square upon 2 plus c3 constant x raised to 6 upon 6 minus x raised to 5 upon 5 plus 5x raised to 4 upon 4 minus 5x cube upon 3 plus 2x cube upon 3 minus 2x square upon 2. It is from 0 to 1. After substituting the value, you'll get c2 into minus 3 plus c3 into minus 0.45, which is equal to 0.333. So this is one equation, equation 4. Now again you need, similarly you have to calculate integral 0 to 1 w to r dx. So to do this, integral 0 to 1 w2 is nothing but minus x plus x cube into r dx as it is. So c2 into minus x plus x square plus 2 plus c3 into 5x plus x cube plus 2 dx. So now again what we have is integral 0 to 1 c2 common, x square minus x cube minus 2x minus x raised to 4 plus x raised to 5 plus 2x cube plus c3 outside minus 5x square minus x raised to 4 plus 5x raised to 4 plus x raised to 6 plus 2x cube minus 2x dx, which is equal to integral 0 to 1 c2 x raised to 5 minus x raised to 4, this is x cube by 2x cube, so plus x cube plus x square minus 2x plus c3 into x raised to 6 plus x raised, so plus 4x raised to 4 minus 5x square minus 2x plus 2x cube dx. So integrating this, c2 into x raised to 6 upon 6 minus x raised to 5 upon 5 plus x raised to 4 upon 4 plus x raised to 3 upon 3 minus 2x square upon 2 plus c3 into x raised to 7 upon 7 plus 4x raised to 5 upon 5 minus 5x cube upon 3 minus 2 x square upon 2 plus 2x raised to 4 upon 4. So substituting this value, you'll get C2 into minus 0.45 plus C3 minus 0.723 minus 0.5 equals to 0. This is the fifth equation. Now you need to solve this equation fourth and fifth so as to get values of C2 and C3. Solving this, you will get minus 0.943 and C3 will be equal to minus 0.204. Now substituting this value in original y, which is equal to 1 minus C2 is 0.943 into minus x plus x square minus C3, that is 0.104 into minus x plus x cube. So now at x equals to 0.5, you have to substitute this value. So y will be equal to 1.274. That is the required answer. Now another example is given as 3y double dash minus y dash plus 8 equals to 0, and the boundary condition is y of 0 equals to 1 and y of 1 equals to 2. So now again, as the highest power is 2, so you can consider a polynomial of degree 3. So if you consider y as c0 plus c1x plus c2x square plus c3x cube, then you have to make use of the boundary condition. So for y of 0 equals to 1, you will get 1 which is equal to c0. Similarly, for y of 1 equals to 2, you will get 2 equals to c0 is 1, so you can directly substitute its value, plus c1 into 1 plus c2 into 1 plus c3 into 1 cube. So this will be nothing but 1 equals to c1 plus c2 plus c3. So c1 will be equal to 1 minus c2 minus c3. Now substituting this value of c0 and c1 in this equation first, you will get y equals to c0 is 1, so 1 plus c1 is 1 minus c2 minus c3 x plus c2x square as it is and c3x cube as it is. Now you need to take c2 and c3 common, so you will get this 1 plus x plus c2 into x square minus x and c3 is equal to x cube minus x. So here this is your w1, this is your w2. Now what we have is this, so this is y, so we have to differentiate it. So differentiating it, you will get y dash equals to, now this 1 it's constant, so it will be 0. Next one will be x, so x equals to 1, so derivative of x is 1. Now c2 as it is, derivative of it is 2x minus 1 plus c3 as it is 3x square minus 1. Again taking double derivative, you will get 0, so c2 into 2 plus c3 into 6x. So now substituting value of y double dash and this y in equation, in the given differential equation, you will get it as, so 3 into c2 into 2 plus c3 into 6x minus y dash, so y dash is this, so minus 1 plus c2 into 2x minus 1 plus c3 into 3x square minus 1 and then plus 8. Okay, so now solving this, you will get a residual function, so r, which is equal to, so 2 into, so it will be 6c2 plus This is 6x c3 minus 1, and this is 2x c2 minus, so plus 1, plus minus 3x square c3 plus 1 plus 8 equals to 0. Now this, solving this, you'll get r of x equals to, taking c2 common, c2 equals to 7 minus 2x plus c3 outside, 1 plus 18x minus 3x square plus 7. Okay, so now as this is r of x, we need to integrate first integration, that is integral 0 to 1 r of x into w1 of x dx, which is equal to 0. Now this will be equal to integral 0 to 1 c2 into 7 minus 2x plus c3 into 1 plus 18x minus 3x square plus 7 into w1 of x is nothing but x square minus x dx, which is equal to 0. So solving all this integration, you can say that c2 into minus 1 plus c3 into minus 1.5167 plus 7 into 0.1667 equals to 0. So value of this is c2 plus 1.5167, c3 equals to minus 1.1667. Similarly, we have to find the second integration I2, which is equal to integral 0 to 1 r of x into w2 of x dx, which is equal to 0. So now again substituting this value, you will get the equation as 1.4833c2 plus 2.4c3, which is equal to minus 1.75. And you have to solve this two equation, this one and this, and you have to find values of c1 and c2. So after finding the value, you can write y of x as 1 plus 2.0998x minus 0.9705x square minus 0.1293x cube. So y of 0.5 is nothing but 1.7909.